In 2023, a structural engineering firm in New York made a single decision that changed everything about how they worked. A structural analysis workflow that previously required 6 full weeks was completed in just 4 hours after they integrated AI into their pipeline. They did not lay off a single employee. In fact, the firm went on to win more complex, higher-value projects than ever before. Right now, at design offices around the world, AI systems are running through thousands of structural scenarios overnight while the lights are off and the engineers are asleep. The question is no longer whether AI will transform structural engineering. It already is. By the end of this video, you will understand exactly what AI structural design looks like in practice, and what you need to do right now to stay ahead of the curve. Let us start with an honest look at where the industry stands right now. Industry surveys consistently show that the vast majority of structural engineering firms globally are still spending more than half of their working hours on repetitive manual calculations. Overtime has become standard practice across the sector, and talent shortages are now a chronic problem in nearly every major market. Meanwhile, the leading global structural engineering firms, Arup, Thornton Tomasetti, Burrow Happold, have already embedded AI-based design platforms as core competitive advantages. This is not just a technology gap. It is a project-winning gap. Firms that adopt AI earlier are processing more projects faster and with greater accuracy. The divide is widening every year. Those who move first gain compounding advantages in speed, quality, and the capacity to take on more ambitious work. For firms still relying entirely on manual workflows, the window to close that gap is narrowing. So what does AI actually do inside a structural design workflow? The capabilities break down into 3 core areas. First, generative structural optimization. The engineer inputs spatial constraints and load conditions, and the AI evaluates thousands of structural configurations to propose the most efficient solution. This used to be a task reserved for seasoned engineers, drawing on years of accumulated intuition. Second, real-time structural analysis. AI integrated with BIM platforms, such as Autodesk Revit, or the open-source Speckle environment, can instantly recalculate load distribution and stress changes the moment a design modification is made. Design and structural review happen simultaneously, not sequentially. Singapore's Cornet X system has demonstrated this at national scale, using BIM-linked automated review to reduce permitting timelines by approximately 40% compared to the previous process. Third, risk prediction. I trained on historical structural failure data. Seismic records and wind load databases can flag potential failure modes during the design phase before a single column is poured. When these 3 capabilities are combined, the result is a structural design process that is simultaneously faster, more accurate, and fundamentally more resilient. Enough theory. Here are the AI structural design tools that are already proven in real-world practice, organized by entry point, so you can match them to your current workflow and budget. Whether you are a solo practitioner or part of a larger firm, there is a clear starting point here for you. Now, let us be precise about something important. AI is not a substitute for engineering expertise, and understanding its limits is precisely what separates engineers who use AI well from those who get burned by it. AI predicts from patterns and historical data. This means it tends to be conservative and can be outright wrong when confronted with genuinely novel structural forms. Zaha Hadid architects, fluid, non-standard geometries are exactly the kind of creative territory where AI's pattern-trained judgment can mislead rather than guide. Beyond the geometry, there are site-specific variables that resist digitization, subtle ground conditions, local construction, traditions, the negotiation dynamics with a specific contractor on a specific site, and critically, legal liability. No matter what an AI system proposes, the engineer of record still signs the drawings, still carries the professional license, still bears the legal consequence if something fails. AI is an extraordinarily powerful assistant. It is not a licensed professional. Blind trust in AI output is itself a risk. The engineers who will thrive are those who deploy AI with precision, knowing exactly where it adds value and exactly where human judgment remains non-negotiable. Let us look ahead to where this industry is heading. The direction is unambiguous. Analysis from McKinsey Global Institute and the World Economic Forum projects that up to 40% of routine structural engineering tasks will transition to AI automation by 2028. This is not a distant scenario. The structural shifts are happening right now, across the European Union. BIM-linked AI review is becoming embedded in building permitting frameworks. In the United Kingdom, AI-assisted structural analysis is already integrated into major infrastructure procurement processes. Across Asia, national digital construction programs are making AI-augmented structural review standard practice on public projects. Globally, firms that internalize AI early will process more projects with leaner teams, compounding their competitive advantage with every cycle. Those who delay face a cost and capacity disadvantage that becomes increasingly difficult to close. The fundamental question every engineer and every firm must now answer is the same one. Will AI displace your work, or will you be the engineer who uses AI to outpace your competitors? Today we have examined exactly how AI is reshaping structural engineering and how rapidly that transformation is accelerating. To summarize, AI automates repetitive calculation work, enables generative structural optimization and early-stage risk prediction, and raises both design speed and quality at the same time. But final engineering judgment, legal accountability, and creative problem-solving in genuinely novel territory, those responsibilities remain irreducibly human. Before we close, one question for you. Is your firm, or are you personally, ready to integrate AI into your structural design practice? If this still feels new, the simplest first step is to install one of the tools covered today and run a test case on a real project. Share where you are in your own AI adoption journey in the comments below. In the next video, we will walk through a step-by-step guide to applying AI-driven BIM